This is integrated 3. It's your lecture for 11.1.4. So you've learned how to add, subtract, multiply, and divide these rational expressions. Hopefully by now you know that you cannot add these up until you get a common denominator. So the easiest way to get a common denominator here is to factor these first and then see what you get from there. So I'm going to go ahead and factor these. So 3 times 4 is 12. So I'm looking for something that multiplies to make 12 and adds to make 13. So 12 times 1. So then I can get so when I factor, I get x plus 4 and 3x plus 1. So I got these things factored, just factored the denominators. Now I can look at it and say, well, what would be a nice common denominator for me? At least they both have x plus 4s in them. So if only this one, I'll use a different color. If only this one had a x minus 7 with it, and this one had a 3x plus 1 with it, then they would match. So like if I gave this one a 3x plus 1 over 3x plus 1, and if this one had a x minus 7, this denominator and this denominator match now. It's a common denominator. And then I know that when I have two fractions and they have the same denominator, all I have to do is add the numerators. So I'm going to leave my denominator alone, which I'm going to write x minus 7 times x plus 4 times 3x plus 1. That'll be my denominator. And then I'm going to add the numerators. So I've got x minus 7 times 2x minus 1 as the numerator from the first fraction. And then this one is the numerator of the second fraction. So now I have to multiply these out because I want to figure out what happens when I multiply these out and combine like terms. Perhaps I can do some more simplification. So you can either use FOIL on these or you can use the little area model box. I'll do the area model box maybe on the first one. So if I want to multiply the binomials like that, it would be 2x times x is 2x squared. So this is 2x squared minus 15 because the 14 and the 1. And then I like to FOIL. You can make another area model box and multiply these out just the same way I did here. But there's also this. You can go x times 3x is 3x squared. And x times 1 is x plus 9x, because 3 times 3 is 9x. That gives me 10x. And then 3 times 1 is 3. And then that's all over this. So this is kind of a long procedure. There we go. And then we're going to try to combine like terms because there's the 2 plus 3 makes 5. And the 15 and the 10 make negative 5x. Okay, and then that, if I want to, I can see, sorry, I just combined like terms. I'm going to see if maybe that factors, and maybe I can factor it some more. The problem told me to just simplify as much as possible. Simplify the result if possible. So it turns out like I've got the answer key in front of me. I know that I can't simplify this anymore, but if I didn't have the answer key in front of me, I would try. And here's what I would do to try to simplify it. I guess this right here is a little bit simplified. I would see if this factors into any of these three factors, because then I could cancel out. I'm sure it doesn't, though, because I can't think of something that multiplies to make 2 and adds to make negative 1 that would even be any of these. So this right here is fine for your answer right here. Okay. And then I'm going to show you just one more, letter B. Sorry, letter C. 11-39, letter C. The rest of these I'm going to let you do them on your own. So this one says I've got 2 over x plus 4 minus 4x minus x squared all over. So I'm going to try the same thing. I don't have a common denominator yet, so I'm going to see what I can do about getting one. Hey, that makes me want to do some factoring right there. I think I want to factor out an x. While I'm factoring, right? This bottom one, this is a difference of squares. So this is going to be x plus 4 and x minus 4. And then when I see these, I want to factor, or I want to cancel them, but I notice that they're not exactly the same. So I'm going to pull this little trick. There's a little trick. This minus sign, if I distributed it inside, then I would have a negative 4 and a positive x. So that's what I'm going to do. I'm going to rewrite it like this. It's a negative 4 plus x. And then you got to be careful. Let me get this written down. You got to be careful. Make sure that what you did didn't mess up your equation. So are these equivalent? Let's see. Negative x times 4. Well, that's the same as if I multiply these two together. It would be negative 4x, and so would this. And a negative x times negative x would give me positive x squared. And this times this also gives me positive x squared. So it's okay that I did that. I haven't broken any math laws or anything. And I don't know if you can tell, but if I switch the x and the negative 4 around, then I'm going to be able to cancel. So let's do that. I just let them trade places in there. Now, instead of getting a common denominator by like multiplying this on the top and the bottom by something, I'm just going to simply do my cancellation now so that I don't have to worry about common denominators. So now I've just got 2 plus x over, right, common denominator. So that's a handy little trick, the little trick where we took the negative and put it inside like distributed it inside the parentheses. So I'm going to leave you to do the rest of them on your own. Um, if you need help, please let me know.